this should not happen. I mean, yeah, electricity is the flow of electrons, but electrons are not that fast. It should take them minutes, if not more, to go from the socket all the way through this cable and up to the light bulb. And yet, when I press the switch, it acts immediately. It's instantaneous. What gives? What's going on? And what is the physics of this whole thing? Hello, I'm Omni Calculator from the Álvaro website, where we have more than 2,200 problems to solve all your calculators. Today's problem is kind of a tricky one. So what's happening here is that when I press the switch, the circuit gets closed and there's an electric field in the wire pushing the electrons. The movement of those electrons, which we call current or electrical current, goes through the light bulb and then we see that as light. The question is, how long should it take for an electron to go from the socket all the way up to the light bulb? Well, let's do the math together. I've put links to all the calculators I'll be using in the video description, and feel free to comment with your personal results just below the like button. Now, the first thing we need to know is the power of my lights. So this fixture has 4 light bulbs, 85 watts each of them, and the voltage standard in Europe is 220 volts more or less. We have 1.5 amps going through this cable, and this cable is comparable to a 12 American wire gauge, so that means 3.3 square millimeters of cross-sectional area. It's made out of copper, so that means it has 8.5 times 10 to the 28 free electrons per meter cubed. That's the electrons that can actually move. Putting all of this together, we arrive at a speed of 0.000034 meters per second. Okay, that doesn't sound like much, so let's see how long it would take to go through this whole cable. Let's say it's a bit under 10 feet, so like 2.5 meters, let's say. Therefore, the electron would take about 25 hours. 25 hours? 25 hours, this is too much. This is so... God, this problem is bigger than I thought. Okay, so let's look at it from a different point of view. When I flick the switch, the light bulb turns on immediately. So it means that as soon as I flick it, there is an electron crossing the light bulb. And that electron cannot be very far, because we know electrons are slow. But how does it know that I flick the switch? It has to be the electric field, because that's what moves electrons. But how fast does the electric field move? Because I only know about one other electric field, that's light, which is electromagnetic field. So the question is...
At what speed do electric fields propagate?
I think I know this. I mean, I did study physics. Okay, it's not B for sure. I think I'm gonna go for C. The speed of light, 300 millimeters per second. Yes! Yes! I told you it was! Yes! Got it right! Sorry about that. I got a little bit overexcited. Let's see how much time that would be to go through the whole cable. 2.5 meters, so it should take 10 nanoseconds. That's basically nothing. That's why it seems instant for us. Let me give you a quick metaphor of what's happening here in case you're not fully illuminated yet. Please, love? Imagine that these marbles are electrons and this tube is the wire. Because the wire is metal, it's filled with free electrons. That's why metals are good conductors. When we flick the switch, almost instantly the electrons are all pushed forwards by the electric field, even the ones far away from the switch. The electron at the light bulb is pushed, so it moves to the light bulb instantly and it powers it. A shocking conclusion from everything we've seen today is that because we turn our lights on for a few hours every day, and because electrons are so damn slow, the electron that's at the switch when you turn the lights on today will take weeks to reach the light bulb. that broke every intuition I had about electricity, just mind-blowing. And that's what I wanted to say about electrons today. But before you leave, here's another video if you want to keep learning. Leave a like on the video if you enjoyed it, subscribe to the channel so you don't miss any future videos. And as always, thanks for watching and I'll see you in the next one. Bye!